This is Tarek L1 presenting lecture number 4 of the SBM4104 IT infrastructure. What we will cover today, we will try to go over the main functions and services, the protocols which are located in layer 3, the network layer, and layer 4, which is transport layer. We will go over the transport layer, the network layer protocol, and that's one of the most important protocol, which is TCP, and the IP as well. Usually we link TCP with IP because IP by itself is not reliable protocol. We will go over few concepts about segmentation, session management, connection oriented, connectionless oriented, and you will start getting a basic view about IP addressing, which you will need that in case study too. We will end up that section, which is, I believe, that's almost like 2/3 of the lecture today. Then we have few slides about the Cisco iOS operating system, how to use the basic command line in Cisco management system. So we tried to link layer 3 and layer 4, the network layer and transport layer together, because they are actually related to each other. As you can see that one in the top of the other one, which means pass data from one to another one. So transport layer and the network layer, usually they are responsible, especially the transport layer, responsible for end-to-end transformation in networking. Send the data from one side to another side. One of the most important protocol inside transport layer, TCP, and the most important protocol inside the network layer, the IP. The IP protocol cannot work by itself. If it's work by itself, or can work by itself, but if it's work by itself, it didn't provide any type of reliability or guaranteed delivery. So what we need exactly, we need to link that or combine those protocols together to TCP/IP, and that's one of the most, if not the most famous protocol on networking. And those ones responsible, usually compatible with most applications. Few concepts and few basic understanding or definition about the word protocol. If anybody still remember from the last 2 sessions, we mentioned that protocol is just only a set of rules and controls. Nothing more than that, nothing more than that. How to connect, when to connect, how to keep the connection, how to terminate the connection, how to freeze, pause, whatever the connections. But it's all about commands, configurations, scripts, programming language, whatever you want to call. It just only sets of rules and controls. Since we cover that, we have each layer, we have famous protocols which link to that layer. For example, we cover the POP. Let me take that one of pins here. Okay, I'll take the red. This is the pub, and this is the SMTP, and this is the IMAP, and we mentioned that before, that those ones related to the emails, the presentation, the session. Today we will go over two main and very famous and very important protocol, which they are the TCP and UDP, and we will compare between both of them. One of them, TCP, is reliable. One of them, unreliable, which it cannot guarantee delivery, which is the UDP. However, it's widely used, which is, and you will understand why is that. Why something unreliable but still widely used around. In internet or network layer in OSI model, we usually focus on these two, the IP version 4 and IP version 6 currently working. We focus on the ICMP. We will not cover much about it today since you are business student. However, the ICMP, one of the protocol which we use it to troubleshoot. And if you are familiar with the command ping, if you ping, which you will do by the way, to make sure that your work is in case study 2, after you do the configuration, you want to make sure that router 1 can ping router 2, for example. What to use? You're gonna use a command called ping. When you ping, that's the protocol you are using, the ICMP. Then you will come to a routing protocol called rep, which is an old version. It's the eldest in routing protocol. You will use that as well in case study 2. So the transport layer, what is responsible for end-to-end delivery from one side to other side. It's responsible for what we call segmentation or fragmentation in short concept. Fragmentation, you break down a big block of data into smaller pieces. Segmentation, the same concept, however, you add few fields, which is you need to add some kind of sequence numbering technique. So when you send it to the other side knows that which one come first before, or which one, when I try to rebuild the block of data, I need to rebuild it or reconstruct it in correct way. I'm gonna show you a small example about that when we come to the slides. The network layer, the main responsibility for the network layer, logical IP addressing, which we go all over, like IP address for the devices, for the router, for the interfaces, and routing, how to route. And I mentioned that before, that the word routing coming from choosing the best path or the shortest and best path. That's how it is. You want to send the data from A to B. A to B can go through many directions. I need to choose the best and shortest path. That's the job for the network layer. If you want to have an example of that, the GPS you use it, or the direction you use actually on your Google map, by the way, use something similar to that, how to route. But in terms of networking here, we're talking about packets, not directions, but in the same concept, how to do the calculation, how to do different calculation and end up using different algorithm away from your totally film study, and come up with, after all your calculation, to send the data through which direction, which can save me time and bandwidth and everything, shorts and fasts. The word encapsulation and de-encapsulation I mentioned to you in lecture 2, and I mentioned that when you go from one layer to another, this is layer 7, the application layer. You have data. When your data pass from here to here, the second layer add what we call it header. For example, this is the transport layer. The transport layer will add a header over here in the top of your data, and this is your data. What we call that encapsulation, adding header. De-encapsulation, which means removing header to the other side of the sending and receiving data. As you can see here, this is your message. If you can see that the transport layer adding in the top of the message, here is you have email only. Here we add TCP. Here we add IP plus TCP from here. So here we add IP. Here we add Ethernet header like this. And the other side it's gonna be other way around. Here I have Ethernet, IP, TCP. We will take over the Ethernet and it's gonna be IP. Over here we will take the IP and it's gonna be TCP, and so on. That's the concept of encapsulation, de-encapsulation, adding header, removing headers. So you mentioned that the main two functions for network layer is addressing, logical addressing, sure, and routing. The logical addressing, how to assign and configure IP addresses. And the other side, the routing, how to route between devices, which path the packet will take. So the IP address, we have two different versions from the IP addresses. In the mid-60s, when they started the ARPA project in the defense in United States, they allocate 32 bits only. So you have 8 bits, dot 8 bits, dot 8 bits, dot 8 bits. And they assume that, this is 2 power 32 devices. I can create up to 2 power 32 IPs. At the time was like really big, huge number, because we haven't assumed that we will have all those small devices and portable devices, and all this computer technology will run in that fast mode. And sure, the project was actually built on for the defense, so they haven't assumed that they will move it into the civilian area. However, when they started the internet and started the computer start to increase through the market, they realized that we have a problem, that these IP addresses, the 2 power 32, it will run out soon. They start come up with some different solutions, something like class and classful, classless. They start adding subnet mask, which we will cover like and so on, to try to solve that situation. At the end, it's whatever you do with the numbers, it's not gonna work. And we have something called NAT as well, which is they have something called private IP and public IP. They have done many things to actually try to solve the situation, but with the increased number of devices, the IP version 4 become non-practical to use anymore. So what they have done exactly, they try to come up with another version of the IP version 4. Usually we multiply the number 32, so they multiply that number 32, make it 64. They found out that it's gonna run in maybe 10, 20, 30 years. So what they have done exactly, they multiply it again and they come up with 128 bits. Sure, for us, I can memorize a 32 bits number, which means that, for example, for me, I can memorize, for example, 10, 20, 30, 40 as an IP address for device. But if you try to multiply that number in 4 and you tell me memorize that, that's not practical. So they have to come up with something different. So instead of using the decimal number under the IP version 4, we will use a hexadecimal. The hexadecimal number is just start from 0 until 9. Then after that there is no 10. There is A, B, C, D, E, and F. So based on here, that number, the base is 10. This number, the base is 16. You will, in this unit, you will use the IP version 4 only. However, you need to have just a basic idea about the IP version 6. That's the size of the IP version 4 and the IP version 6, the header. That IP version 4, 24 bytes, which is quite a little bit average. The IP version 6 is 40 byte, which is a little bit quite big. How to work with the IP addresses? We have different type of addresses, sure, just only to understand a basic concept. We have addresses which is related to the application layer, which is something like URL, www.abc.com. No problem, that's a URL. When it comes to the layer 3 or the network layer, you need to use an IP addresses. The IP addresses at that time, you need to use either private or public, but however, you need to use 4 sets of sequence of number separated by the dots, as you can see here, 4 bytes. The data link layer, which is layer 2, this is layer 2 addresses, this is layer 3 addresses, and sure, this is layer 7 addresses. The data link layer work with the MAC addresses, and I believe that we covered that last session, the MAC address, the physical MAC address of the network card. How to identify and use the IP version 4 and version 6? IP version 4 is 32 bits, 4 bytes separated by decimal dots. The IP version 6, it's actually 16 of those ones separated by colon, as you can see over here. It's a colon, not a dot. And when we type not just number, we type hex number. For example, this one represent 10, this one represent 15, and so on. You may get a chance to study IP version 6, but for now we will, or for this unit, we will focus much more about the IP version 4. Since you actually familiar with the byte over here, 0000, 0000, that's 2 chunks. The total number, I can put it over here, 256, which is 2 power 8. The first number I can put is 0. The last number I can put over here, 255, and that's what you can see over here. I can start from 000. I can end up with 255, 255, 255, 255. The total number of IPs address can be allocated within IP version 4, 4.3 billion address. The total number we can create it here something around 32 times 10 power 37, or you can put it as dot 38 if you want to even number. That's a huge number of devices. How the IP usually structures? Well, we have break down the IP address, since the IP address is like this, here, here, here. So we break this into two different sections. One section we call it the network ID, which is related to the network, and this number cannot be assigned to a device. So you cannot put this number into assign it into computer, for example, or server. The host, that's the number you can assign it into the host or devices, computer, servers, any other device. The dot decimal, which is separated the 4 bytes. To make things much easier, after they figure out that the 4 bytes or 32 bits will not be enough and it will not be actually cover all the devices, it's gonna run out soon. So they separate the numbers into two type of addressing. What we call it classful addressing, which has some certain numbers, and it's gonna be if you use it, you have to use static network size and static host size. That's how it is. That's how it is. Do we have another type? Yes, we have another type, which is even the number located here, we can use what we call it CIDR, which is variable addressing, which is VLSM, away from your current study. However, what exactly is that classful addressing? Classful addressing, you have the 4 bytes like here. Actually, let me show you in a better version. What is that exactly? Here it is. The class A. What is class A exactly? If you have the first oct, which is the first byte, if you have the first oct, if you put any number here from 1 to 126 in that one, that number has to be classified as class A. That's how it is? Yes, that's how it is. If you put any number here, if the first oct, the first byte, between the number from 1 to 126, the end of 126, that means that has to be classified as classful A, class A. And the first oct will be network, and the 3 other octs or the 3 other bytes will be assigned to host. What that mean? You have 8 bits for network and 24 bits for host. Host means computer, servers, whatever it is. So that one we use it usually when if you have a big huge company with a lot of employees, you can use that. You have up to 200 and you have 2 power 24 of device address. You can assign to devices. For that one, class B start from 128 to 191. If you have any number starting here, you want to start from 128 191, that means that gonna be classified as class B. The class B, the first 2 bytes will be for the network, the other 2 bytes will be for the host. So you have here 2 power 16 of devices, IP addresses you can be assigned to devices. Class C from 192 to the end of 224, and that one, as you can see, the three bytes over here can be a network, and only you have 1 byte only can give you for the host, and this one can give you only 2 power 8. Sure, minus 2, but 2 power 8 for now, for just only the sake of this lecture. You can put 2 power 8 or 1 byte for the host. Alright, for example, let me give you an example of that. When you have a network which starts with, for example, 10 0 0 0, that one under the class full addressing has to be class A directly. Over here, when you have 172, that has to be under class B. As you can see here, 192 has to be class C. What the difference between those ones? The portion of the network, and that the portion of the network, that we call it the subnet mask. The subnet mask over here, as you can see, how many byte over here in class A for the network? 1. So the subnet mask, how many? It's 1 as well. So the subnet mask is the portion of the network in the IP addresses. So over here I have 1 byte as a network, and the subnet mask I have here, and those, as you can see, 0 0 0. Okay, how many here I have for the network portion? 2. So this is 255, this is 255. That's the subnet mask. To identify that host, you need to link the subnet mask into the network portion. This one, 3, as you can see over here, 255, 255, 255, and 0. So the 3 bytes network reflected in the subnet mask, each one 255, 255, 255, and I left you only 1 for the host. Since that 1 for the host, I left you 1 byte here, which is 0. The subnet mask is the portion of the network, the portion which represent the network and the host. The network specifically, the network portion in the IP address, the portion which represent the network piece in the IP address, which is version 4. As you can see over here, as of class D and class E, we use it for testing, but that's away from your study for now. Class D and class E. As you can see over here, class A, for example, that's 10, class B 172, class C 192, and it has to be, class A has to be like this. The subnet mask has to be like that. Class B has to be like that, the subnet mask. Class C has to be like that, regardless. Sure, we have another way we can play with that, which called VLSM variable, which it is not static like that. We can play with that. However, that's totally away from your study. Why we jump from here? This is, as you can see here, this is 126 and this is 128. Where is 127? 127, as you may know, it's reserved for loopback by Microsoft for testing, or IEEE for testing or troubleshooting. The IP version 6, it's taken the market, by the way, rapidly. It's taken over the market. It's easy to be configured. A lot of IPs can be allocated. It has a lot of advantage over the IP version 4. And some of it actually as well, you may know later than self-configuration. But for now, that's the thing you need to know about that. This is an example of if you have an IP address like that, if you have 149.61.10 dot whatever the number is, as far as like you see 149, you ask yourself, 149 under class what? Is that class A? But class A until 126. That's a class B. Okay, so that if that's class B, so the subnet mask will be what? So 255.255.0.0. So why we have here 255.255.255.0.0.0.0? That's one of the things you need to search for that. However, since we do not have class full addressing, we can play with that a lot, and we can put multi-numbers. As you can see over here, we can put from 1 to 128. Why is that? You will learn that during the lab. Here we will come to very interesting area, which is the comparison between two main famous protocols, TCP and UDP. TCP is reliable, UDP unreliable, which means TCP guaranteed delivery, UDP do not guarantee delivery. TCP is connection oriented. What that mean by connection oriented? If you use TCP between that connection and that connection, or that device and that device, and you want to use TCP, what TCP will do first? Before it sends the data, it will try to communicate to that device first. Hello? Yes, hello. Can we communicate? Yes. Now start sending the data. The hello and that one, we call that establishing a virtual circuits. In short, to see that, you have to establish connection first before you send the data, which means that the other side of the connection, they knows that you will send a data and waiting for the data. How to remember that? Remember the phone system. If you want to remember what's connection oriented, remember the phone system. Before you talk to anyone, what you usually do, you need to create a virtual circuits, which means that something temporary. You create a circuit, then when you finish to terminate it. That's how the phone works. You call someone, that you ring. If someone accepted the call at the other side, that means accept the establishing the VC or the virtual circuits. After you establish the virtual circuits, what's happening? You start to talk, and that talk is the data. You start exchanging data. When you finish, what you do exactly, you terminate that circuits. The phone system is the best example if you want to remember what is connection oriented. So why TCP is reliable? First, connection oriented, which means that the receiver knows that you have to, the sender and the receiver, they have to communicate first, and they agree to establish a virtual circuits before they send the data. Alright, what else? When the sender send the data from here to here, for example, you send it with sequence. For example, this is data sequence 1, sequence 2, sequence 3. When you send the data here, that receiver has to send you acknowledgement. A1, A2, A3. Really? Yes. So every time I send a frame or packets, whatever, or chunk, whatever you call it, or block of data, I receive acknowledgement for that? Yes. What about if I didn't receive that acknowledgement for a piece? For example, I got acknowledgement for 1, 2, but I didn't get acknowledgement for 3. So what to do exactly? You wait for whole time, then after that you assume that you lost it. So you send it again. So you send sequence 3 again, the block number 3 again. What is that exactly? That's guaranteed delivery. There is no piece of the information will go. So you get sequence number 1, 2, 3, 4, 5, 6, whatever it is. You need to receive acknowledgement for those ones. If I didn't receive acknowledgement for that one, that means I assume this one is dropped and I resend it again. Is that good? Yes, it is in somehow. Is that bad or disadvantage? Yes, in somehow, because usually it consumes time and create delay for sure. That's reliable. Packetization, that's the similar to segmentation, defragmentation, breaking a large data into a smaller size. However, the transport layer function, it links to the application layer, the top application layer with the 3 inside layers, the session and the presentation as well. We have the segmentation, we have the session management, if it's connection oriented or connectionless oriented. Who's using connectionless? The UDP, which you will see later on. The connectionless oriented, that's the UDP as a protocol, use that. However, the functions, session management, connection oriented or connectionless oriented, and we have quality of service. What's quality of service exactly? Priority. You classify the data. The most important data pass first. The less important data goes back, stay like VIP. So you have very important data, medium data, whatever. This is usually classified from 0 until 7. However, that's for that only. Quality of service means data classification and priorities. How TCP communicate and open different application at the same time? I think you're familiar with the tab you're using for the URL, for example. You can, in HTTP, you can use multi HTTP on the tab. for example, you have that in URL, you can open tab here and tap here and tap here, and this one you browsing website, this is another website, this is another website, for example, or another data or email, whatever you like. How that works? Through something what called ports, different type of ports. TCP using the same concept like that, similar to that. How to TCP connect to something like that? TCP usually work with ports numbers, different port numbers. How that port numbers been allocated? We have standard one, which is, you can say that, the known one, the well-defined one, the one we know it, and you can just type ports number in Google and you will see that, or network ports. You will find a list of those ones. The famous one, which you may familiar with, 80, that's for HTTP, FTP 21, SMTP 25, SSH 22, and so on. We memorize few of those ones. So you can run multi-application using STP through different type of ports and no problem at all. We have non-standard one, which you actually can configure. By the way, if you want to, you can configure those ones. However, that's another issue. The packetization and the assembly, you need to understand there is something called MTU, or maximum transmission unit. The normal network, or the actual, the majority of the network we use, the cable or the bandwidth here, whatever the cable you use, it work with a standard size, cannot be exceed in normal networking. The maximum that size can be 1500 bytes. Really? Yes. So can't I go over that? If you have a special network, yes, but if normal network, 1500 bytes. Alright, so if I have let's assume that you have a 4000 byte. I have here a block of 4000 bytes. I want to send those 4000 bytes here. What the packetization and reassembly will do, and that's one of the layer advantage or function as well, or the TCP does. You have to break this one into 1500, and this is 1000. Oh, but if I put 1500 and 1000, I need to put some fields, which is, we call it header. The header, which is the field which you can direct, you put the source, the destination, the port number, who's the sender, who's the receiver, the sequence number, the field, the flag, the priority. We have header has to be add. If I want to add the header usually, which is this one, is 20 megabyte. If I want this, if I put this one in the top of 1500, become 1520. That cannot go through the normal network. So what to do exactly? We have to cut 20 byte from here. So this one will be 1480. This one will be 1480, and this one will be 1040. And we send, and you start sending. By the way, that field has sequence number. So this is, for example, this is sequence number 3, this is sequence number 1, or this is sequence number 1, 2, 3. No problem. When you send it over here, This is the sequence. Number 3, for example, this is here is the fill. This is 3, 2, 1. What's the packet will go? You will take this one off, this one off, this one off. This is sequence number 1 here. This is sequence number 2 here. This is sequence number 3. That's the data has been arrived. That's the concept of packetization and reassembly. How to break a large data into smaller size and then you rebuild it again. The connection or the session management, connection oriented or the connectionless oriented, TCP based on connection oriented. Before I send you a data, I have to talk to, like not to talk, I have to let you know first that I'm gonna send you a data and you agree on that and you wait for the data. UDP is not. UDP based on I'm here, I want to send the data to someone else through anywhere. Do I have to let him know? No. Do I receive from him that he's gonna send the data? No. Do I expect that it's gonna be a virtual circuit between me and him? No. What do you do exactly? You send the data. However, it arrived, it didn't arrive. Which direction will take is not your business or not my business. So did he knows that he has data coming to him? No. Did he know if he received the data? No. Really? That sound like non-professional protocol. It is. However, because of that, no limitation, there is no sequence, there is no acknowledgement, there is no security on it, there is no resending the data, there is no what they call it window slide. So that things make it faster. UDP, it's faster than TCP. TCP has a lot of checks, sequence, numbering, then acknowledgement, then packet dropped, then I have like that. So what we do exactly, UDP is much more faster, and that's why a lot of the videos companies or videos you can see, it's actually downloaded or uploaded using UDP. The network management, usually protocol we use in the top of UDP. We prefer that. And when you compare between TCP and UDP, you will find that it's much easier. The quality of service, as I told you, that it's based on classification and priority of the data. And I'm gonna give you example of that. If you are a router, for example, or if you have protocol, and then you have 2 packets, one audio and one video. One audio, one video. Forget about that. If one audio, a packet which carry or frame or block carry a audio message, and another packet which carry an email message, which one you will process first? Think about it, Google, and get back to me. This is how the TCP works. You send the data. This is synchronous back, the data. Here it is. Hello. Can we talk? Yes, no problem. This is the data, data 1, data 2. I give you acknowledgement, data 3, acknowledgement. Then we have finish. Yes, finish. That's it. That's it. So I need to receive acknowledgement from you. The UDP in the other side, which is faster, there is no flow control. The flow control, which is TCP by the way, and that's what we have mentioned about the window slide. What is that flow control to understand? TCP, if you want to send the data from here to here, how I guarantee that, how to make sure that A will not overwhelm B with a lot of data which you cannot handle. So for example, you send me data, I cannot handle all that. How can we guarantee that A will not overwhelm, which means that flood B with data which cannot handle? That's what we call it flow control. We have techniques to do that away totally from your study, but you need to just only understand the concept flow control. UDP doesn't have any flow control. That's why it's faster. Send the data, arrive, didn't arrive, who cares? But it has its own use. The comparison between TCP and UDP, as you can see here, reliable, unreliable, sequence or order, no order, heavyweight, which is create latency and delay. The UDP is lightweight, which is faster. This one based on stream, byte per byte. This one is block per block. Flow control, no flow control. No broadcast, no broadcast. That one can broadcast. What is no broadcast? The word broadcast, when you send from one device to all devices. One to all means broadcast. The implication of management, some has used. So TCP to be considered one of the top protocol in the market, and it's been used widely used. UDP has its own use, however it's been used in videos, the heavy traffic load, which is videos, something like FTP and the downloading, uploading, network management, traffic, something like that. The last piece for today, which is related to the Cisco iOS, and that's one you will see on your own packet tracer program. When you the software, when you grab any of these devices to the packet tracer, you will find it's loading. Usually the iOS in Cisco, it's based on number, then the version, and then the subversion, which is sometimes like 14.4.3 for example, like that, the current version. The thing which you need to focus on, and that's the one I want you to, let me take you to the end here. The router. When you start the router or switch, you will find in front of you the name of the device, either router or switch or whatever, or ASA, and you will find something like this. What is that exactly? Unfortunately, Cisco commands work in different level, not in one level. What do you mean by that? Certain commands has to be executed in certain levels. Really, yes. So do I need to go to the configuration level to configure devices? Yes. But can I put it in the normal mode? No, you can't. So if you want to configuration, you have to go to the configuration level. If you want to execute something, some certain, each line has it, or level has its own command set. How to find out that? If you have, for example, I want to find out what command I can type in that mode. Very basic. Put question mark, type question mark, and hit enter. It will give you only the command you can put it in that level. So what about if I came over here? So for example, here mostly what we call it here, the user execution mode or the user execution level, what I can type here, mostly we type enable, or we call that enable mode, which you will see that when you type that the word enable, you will find yourself here, and that level has been changed to ampersand. What we call that privilege execution mode. If you want to see what command, you can type it here, just put a question mark. And over here we can type command from copies, like if you want to copy data, copy means like copy startup. You can type erase, release, whatever. You can type many commands here, however is limited as well. Okay, so you want me to type enable here, yes. And over here if I want to configure, what I can type config T or configure terminal, the short for that config T. Okay, it's gonna take me to the router configuration mode, and here the configuration. As soon as you come over here, you will find the word config. Now you can configure devices. Sorry. And here you can type all the commands you will learn later on about how to configure IP addresses, how to configure interfaces and everything. Now if I want to go to specific interface, for example, I want to go to the interface gig Ethernet. For example, here it is, interface gig Ethernet 0/0. It will take you inside here. When you see the word the F, that means you are inside the interface, and at that time you can type over here IP addresses 192.168.10.20 255 subnet mask 255.255.0, for example. That's it. And after that, no shut. So to turn on, no shut. To turn on to bring the interface up. Up to here, this is mostly the level you will use. You will not use that kind of the router engine level or the line level. You will not use the VTY or these issues for that unit. However, this is the one you will use in that, especially in your case study. Number 2. To see an example of that, here it is. This is, you are here, you type enable, it take you to the switch here, you type config T, it take me to config T, you put the host name if you want to change the host name, if you want to add any message to the screen like this, if you want to add password, if you want to add another password to the to make the password secret, nobody can see it, and so on. What is that exactly? Different type of command, and you will learn these type of command in the lab, but step by step. You have a command over here in the privilege mode over here, as you can see. What is that exactly? Copy running config to startup config. As you can see here, startup config. Copy running config to startup config. As you can see here in the top, run config to startup config. You will do a couple labs about that, and you will practice doing the case study too. You will allocate the IP addresses, you will configure 3 different devices, 3 different routers, and as well you will configure servers and routing protocols. I hope that will be was beneficial, and if you have any question, come back to me with any question and I'll be more than happy to answer all. Have a good day, and I'll see you soon.